The difference between intermolecular forces and intramolecular forces is that intermolecular forces are attractions between two separate molecules. Intramolecular forces are attractions within a molecule.
Intermolecular forces. Intermolecular forces are the forces of attraction that hold two molecules together. London dispersion forces are one kind of intermolecular force. They are the weakest type of forces, and named after scientist Fritz London. London dispersion forces occur due to the asymmetrical distribution of electrons in an atom, forming instantaneous dipoles. They can occur between any two kinds of atoms. Depending on the polarizability of an atom, or the ease by which electron distribution can change in an atom, London dispersion forces can be stronger or weaker. They are stronger between molecules that are easily polarized. The shape of molecules can also affect the strength of the London dispersion forces. Large atoms usually contain valence electrons, which are farther away from the nucleus and less tightly held, that can hold temporary dipoles more easily. Dipole-dipole are the kinds of forces between the positive end of a polar molecule and the negative end of another polar molecule. The partially positive end attracts to the partially negative end. Dipole-dipole can only happen between polar molecules because it's an attraction that connects two already permanent dipole moments in molecules with an imbalance of electrons. Molecules need to be very close to each other for this force to exist. It is a permanent force that connects the two separate molecules together. While London dispersion forces are the weakest kind of intermolecular force, dipole-dipole forces are the second strongest. Hydrogen bonding forces is a type of dipole-dipole attraction that occurs exclusively between hydrogen atoms bonded with oxygen atoms, as well as nitrogen atoms or fluorine atoms. It is also known as an electrostatic attraction, meaning the negatively charged atom would be attracted to the positively charged atom. Like in dipole-dipoles, hydrogen bonding is the attraction of the partially positive hydrogen atom to the partially negative end of either oxygen, nitrogen, or fluorine. Of the intermolecular forces research, hydrogen bonding was the strongest kind of attraction. Boiling point is one of the properties affected by the different kinds of intermolecular forces. Boiling point increases with molecular weight and greater surface. Without any substance to change its current state of matter, the forces of attraction need to be broken off between the molecules and overcome by a certain amount of energy. Stronger intermolecular forces require a greater amount of energy because the molecules are being held more tightly together. This is why water, which has molecules with hydrogen bonding, the strongest kind of intermolecular force, has such a high boiling point. This chart shows the relationship between intermolecular forces and different properties. The second property I researched was viscosity, which is the resistance of water to flow. For example, honey has a high viscosity, while water's would be much lower. Like boiling point, there is a direct relationship between the viscosity and the strength of intermolecular forces, and viscosity increases as the strength of the intermolecular force increases. Additionally, as temperature increases in liquids, the strength of the intermolecular forces decrease, and so does viscosity, as molecules are able to move more easily. Molecular weight increases viscosity because it does not allow molecules to move as freely. The last property I researched was surface tension, or the measure of the toughness of the surface of a liquid. Surface tension is greater when the strength of intermolecular force is higher, because molecules will have a higher tendency to stick together. Surface tension is especially present in water, as hydrogen bonds the strongest kind of intermolecular forces, and it is why water bugs can land on top of water. A certain amount of energy is required to break surface tension, and essentially the hydrogen bonds. I related intermolecular forces to the different kinds of relationships in real life. Dipole-dipoles can be compared to marriage since they are permanent bonds created by two polar molecules attracted to each other. London dispersion forces can be compared to young love because they are short and instantaneous bonds that are formed when electrons are distorted. Just as in a relationship, when you're young, it usually does not last very long and is a very short, weak kind of love. Hydrogen bonding can be compared to an engagement because it is the strongest kind of intermolecular force and requires lots of energy to break this bond. Just as immediately after an engagement, the relationship between two people is extremely strong and would require lots of turmoil to break it off.
The first compound I looked at was beryllium fluoride. I drew the Lewis structures and discovered the only intermolecular force present between the two molecules was London dispersion forces. I discovered this because beryllium fluoride is a polar molecule and does not have the qualities that would allow hydrogen bonding forces to form. Beryllium fluoride has ionic bonding, which is a type of intramolecular force between a metal and nonmetal, which is a charged compound. This makes the bonds between molecules even stronger. Thus, viscosity, surface tension, and boiling point are very high because it takes much more energy to overcome these forces. The second compound I looked at was pH3, or phosphine. From looking at the Lewis structures, I noticed pH3 was a polar molecule, allowing for both dipole-dipole and London dispersion forces because the partially negative side of phosphorus attracts the partially positive side of hydrogen, connecting the two dipole moments. pH3 does not have a hydrogen component to the compound, but none of the other elements bonded to form hydrogen bonding. pH3's boiling point is negative 87.7 Celsius. pH3's viscosity, surface tension, and boiling point are lower because the intermolecular forces are weaker. The last compound I looked at was H2O. H2O is a polar molecule that has all three intermolecular forces present. London dispersion forces are present in all compounds. H2O creating a dipole moment and thus an attraction between the partially negative and partially positive sides. Finally, H2O has hydrogen bonding forces because hydrogen is bonded to oxygen, one of the elements that creates hydrogen bonds. H2O has a boiling point of 100 degrees Celsius. The viscosity and surface tension of H2O is very high because the intermolecular forces between the molecules are very strong.